Hello students, today we are going to learn the second method of rationalization. Now we have seen previously that rationalization is the process where we remove surds from the denominators. When we remove surds from the denominators, we basically simplify a fraction. In the first method, we have seen that the first method was applicable to examples where we had one surd in the denominator. In the numerator, you can have a surd or you might not have a surd. But the surd in the numerator was not a problem for us. The surd in the denominator was. So we have seen how to remove this surd in the denominator in the previous lecture, where we multiplied with whatever the surd was given to us. We multiplied with that surd to rationalize the denominator. Now in today's lecture, we will be trying to deal with multiple surds in the denominator. Today we will try to see what happens when we have a problem as such, or a minus in here. So when we have a combination of numbers where we have more than one term in the denominator, then we multiply the conjugate for rationalization. Now, what is a conjugate? So a conjugate is a number which again is a number of this type, a combination of this type, which has the opposite sign to the one given. Conjugates exist in pairs. If you have, let's say, a number of this type, root 2 plus 3, then the conjugate of this number will be root 2 minus 3. A conjugate is a number which contains the opposite operation. A conjugate is a number which has a numerical value which will not be the same as this one. And how does this value differ from this one? When you have a different sign in the center. If you have a plus and you change the plus to a minus sign, you get the conjugate. If you have a minus sign in here, let's say we have a 2 minus root 5, then the conjugate will be 2 plus root 5. And this applies when you have two surds as well. If you have root 2 minus 5, then the conjugate will be root 2 plus 5. If you have root 2 plus 3, the conjugate will be root 2 minus root 3, like this. So what we will do is, we will multiply with the conjugate. Now, why will we multiply with the conjugate? The reason for that is, when you multiply conjugates, let's say the previous one that we had, the previous conjugate here that we had was root 2 plus root 3 and root 2 minus 3. Conjugates always exist in pair. This one is called a conjugate because this one exists. So when we multiply the conjugate, see, you have root 2 plus 3 and then you have root 2 minus 3. So this one is the same as what we have seen earlier. This is A, this is B, this is A plus B, and then this is A minus B again. So we know that the formula for A plus B multiplied with A minus B is A square minus B square. We have learned this formula. So we are going to apply this shortcut in here. So we get A square, which is root 2 squared minus B square, which is 3 squared. So we are going to get the square and the roots get cancelled out. So we get 2 from here, and then 3 square is 9. So we are going to get minus 7. Again, if you multiply these two, see, you will be going to get, you have two conjugates. The conjugates are root 2 minus root 5 and root 2 plus root 5. So when you multiply this, you get A minus B into A plus B, which is A square minus B square. So the square and the roots get cancelled out and you get 2 minus 5, which is minus 3. It will always not be a negative number. If the first number is, the square of the first number is a bigger one, then it will be a positive number as well. But in both, from both the cases, what we can see clearly is that these numbers do not contain any surds. So the speciality of conjugates is that when you multiply these two numbers, you do not get any surds in it. So this is the reason why we multiply with a conjugate. If you have root 2 plus 2 given, your conjugate will be root 2 minus 2. The reason for that is if you multiply these two, you are going to get a number in the denominator which removes our surd, and that is what we are aiming to do here from the denominator, right? So let us try to see an example to understand whatever we are doing in here. So now, in this example, we do not have only one surd like the previous examples. We have two surds, two terms. Both of them are surds in this case. And in the numerator also, we have a surd. But we know that a surd in the numerator is not a problem for us. So we have to deal with the denominator in here. And to remove surds from the denominator, when we have a combination, what do? We multiply with the conjugate. So we are going to multiply with root 7 minus root 2 because there is a plus in here. So our conjugate will be the one with the negative sign. So what do we do here? We multiply with the negative sign. So root 14 divided by root 7 plus root 2. As per our rule, we have to multiply with the conjugate. We have multiplied with the conjugate. But can we out of nowhere multiply the denominator with any number? We cannot do it. So we have to multiply the numerator with the same number as well to balance out the question that was given to us. So root 7 minus root 2. Now we follow the same steps that we have been doing earlier, the same procedure. We multiply the numerator with the numerator and the denominator with the denominator. So we have root 14, root 7 minus root 2. Then we will multiply the denominators, and in the denominators we have root 7 plus root 2, root 7 minus root over 2. Now we know the methods of expansion when we multiply. So we can simply multiply. We know we have to multiply 14 with 7 and then 14 with 2. So we will be getting 14 with 7, which is 14 into 7 because both are numbers inside the root. And then again 14 and 2 are both numbers inside the root. So we can multiply them as well. Then in the denominator, we have a plus b and a minus b. This was the reason we multiplied with the conjugate in the first place, so that we can use the shortcut and simply write it as a square minus b square and remove the surds. So we will write a square minus b square. So we get, now in the numerator, we know that in order to simplify, we have to go for prime factorization, right? We have to go for prime factorization. So the task that we have to do is, instead of multiplying 14 with 7, you try to write 14 as a product of its prime numbers. It's easier. It saves us a step. So we will write, in place of 14, we know 14 is 2 into 7 and both 2 and 7 are prime numbers. Then minus, for 14 again, we write 2 into 7 and then this 2 was already in there. This divided by 7. For this root 7 square, we know the square and the roots get cancelled out. So we get 7 minus the square and the root again gets cancelled out. So we get 2 in here. Now, when we are simplifying, we know for every two numbers, one number comes outside. From these 2 and these 2, 1, 2 will come outside, right? So we have 7 root over 2 minus 2 root over 7 divided by 7 minus 2 is 5. Now we see that you have 7 root over 2 minus 2 root over 7. You cannot subtract 7x from 2y or 2y from 7x, right? We cannot do so because x and y are different variables. Similarly, root 2 and root 7 are two separate numbers. So we cannot subtract this 2 from this 7. And then you cannot take anything common as well to cancel out with 5. So this remains as our answer. This is how we rationalize when we have multiple surds in the denominator. Let's take a look at another example in here. In here we have surds in the numerator and surds in the denominator. But we know surds in the numerator are not a problem for us. Surds in the denominator are. And we have a plus in here. So our conjugate is going to be the one with the negative sign. So we multiply that. We multiply with 2 root over 3 minus 3 root over 2. And to balance this one out, we have to multiply the numerator with the same thing. Now in the next line, we know that we have to multiply the numerators and the denominators. So we have got 2 root 3 minus 3 root over 2 into 2 root over 3 minus 3 root over 2 in here. And in the denominator, we are going to have 2 root 3 plus 3 root 2 and 2 root 3 minus 3 root over 2. Now see that in the numerator you have the same thing. 2 root 3 in here, 2 root 3 in here, 3 root 2 in here, 3 root 2 in here. So this must be a minus b and a minus b, which is a minus b whole square. So you can directly apply the formula when you are multiplying. Or if you want, you can go for the method of expansion. You multiply this 2 root 3 with this 2 root 3 and then with this one. Then this 3 root 2 with the whole bracket. How you have done the expansion. So in the numerator, we have 2 root 3 minus 3 root over 2 whole square. And in the denominator, we have 2 root 3 plus this 3 root 2 and then we have the same numbers but separated with a minus again. So this must be a plus b and a minus b. So this gives you a square minus b square. So for a plus b whole square, we know the formula is for a plus b whole square. We know the formula is a square plus 2ab plus b square. And for a square minus b square, the formula is simply evaluating a square and b square. So we have 2 root 3 squared minus 2 root 3 root 2 plus 3 root over 2 squared divided by, now this square is over both 2 and root 3. So it becomes 2 square root 3 square minus, in the similar way, we have 3 root 2 whole square, which means because the square is over the whole bracket, it would mean that the square is over both 3 and root over 2. So we will get, let's first sort out the denominator. So 2 square is 4 into root over 3 square. The square and the roots get cancelled out. So we get 3. Then minus 3 square is 9 into the square and the root gets cancelled out. So we will be left with 2 only. Now 2 root 3 square is evaluated in this same way. So we know that we are going to get 4 into 3 again in this case. Then minus. We know that for in case of multiplication, for multiplication, we multiply the brackets, we multiply the numbers outside of the root and the numbers inside of the root separately. So this 2 is outside of the root. This 2 is outside of the root. This 2 is outside of the root. This 3 is outside of the root. So when you multiply all of these 3, you get 2 into 2, 4. 4 3s are 12. And then inside the root, what do we have? 3 and 2. So 3 into 2 gives you 6. Then plus this 3 root over 3 into root over of 2 whole square gets evaluated in this same process. So we are going to get 9 into 2 from here. So 3 4s are 12 minus 12 root over 6 plus 2 9s are 18 divided by 12 minus 18. Now a common mistake that everyone does is they either cancel this 12 out with this 12 or this 18 out with this 18 or this 12 with this 12. You cannot do any of these. These are all mathematically wrong because cancelling out comes from taking common. And when you take common from this 12 and this 18, you cannot take the whole of 12 or the whole of 18 as common. So that is not a valid technique. Now we add the numbers. This is 12 plus 18. So 12 plus 18 is going to give us 30. So we write 30 in here, then minus 12 root over 6, then divided by 12 minus 18, which gives us minus 6. So in order to cancel these out, we can see that we can take 6 common from both 30 and 12. So if we take minus 6 common, because we have minus 6 in the denominator, so let's take minus 6 common. If we take minus 6 common from 30, we will be left with minus 5, because see, minus minus makes it plus, and then 6 and 5 makes it 30. So this minus we have taken common, so we will be left with plus. And then when you take 6 common from 12, you get 2. And then we have root over 6 divided by minus 6. So now this minus 6 can get easily divided with this minus 6, or what we like to call it, that this minus 6 gets cancelled out with this minus 6, and we are left with minus 5 plus 2 root over 6. Now, if you put the question given to you in the calculator, you are going to see that the calculator gives us this as the final answer. So we will be very sure that we have done the sum accurately. Now, let's move to the next one. In this one here, we have a similar problem like the one we just now solved. There are surds in the numerator and there are surds in the denominator. But we know a surd in the denominator is not a problem in the numerator is not a problem for us. But the surd in the denominator is. So we need to remove that. And in order to remove that, what should we do? We should rationalize. And for rationalization of such fractions where we have more than one surd in the denominator, we multiply with the conjugate. So what will the conjugate in this case be? We have a minus sign in here. So our conjugate will be the one containing a plus sign as the operator. So we have 3 root 5 plus 2 root 3. Now we know in order to neutralize this, we have to multiply with the same thing in the numerator. Now, all we need to do is multiply numerator with the numerator, denominator with the denominator. So we have 7 root over 3 plus 2 root over 5 multiplied with 3 root over 5 plus 2 root over 3 divided by 3 root over 5 minus 2 root over 3, 3 root over 5 plus 2 root over 3. Like the previous case, now we do not have the same numbers in here. So we cannot go for the shortcuts of using the formula of a plus b whole square or a minus b whole square. We have to multiply this manually. That we have to use the expansion formula. The expansion formula needs to be used here. So we know the expansion formula, the 7 root 3 will get multiplied with 3 root 5 plus 2 root 3, and then 2 root 5 will get multiplied with 3 root 5 plus 2 root 3. And then in the denominator, you have 3 root 5, 3 root 5, 2 root 3, 2 root 3, a minus in here and a plus in here. So you know that this definitely is the a plus b and a minus b format. So this will be a square minus b square. In case of rationalization problems of this type, the denominator always is going to be a square minus b square. So we get 3 root 5 whole square minus 2 root 3 whole square. So we get to multiply these now in the numerator. Now, when we multiply these in the numerator, we know that the numbers outside the root get multiplied, the numbers inside the roots get multiplied. So 7 into 3 gives us 21. And what are the numbers inside the root? The numbers inside the root are 3 and 5. So root over 3 and 5 gets multiplied to 15. Then plus the numbers outside the root are 7 and 2. So 7 and 2 gets multiplied to 14. Root over the numbers inside the root are 3. So root 3 and 3. So 3 and 3 gets multiplied to 9. Then plus again the numbers outside the root 2 and 3. They will get multiplied to 6. The numbers inside the root 5 and 5. 5 and 5 gets multiplied to 25. Then plus the numbers outside are 2 and 2. 2 2s are 4. And the numbers inside 5 and 3, which make up 15. Then divided by, we have a square over the whole bracket. So it means that the square is over both 3 and root 5. So we have the square over both 3 and root 5. Then similarly, we have this square over both 2 and root 3. So over both 2 and root 3, we have given the square. Now in the next step, we have 21 root 15 as it is, because you cannot simplify any one of these from here. Let me write 15 nicely. And then we have root over 9, which simplifies to 3. We all know root 9 is 3. So 14 into 3. If you wanted, you could have written this step directly. Then we have 6 into root 25 is 5. We all know. Then we have 4 root 15, which you cannot change or simplify to any further. And then we have in here 3 square, which is 9. And then root and square gets cancelled out. So we have left with 5 only to us. Then we have 2 square, 4 into root over, and this square gets cancelled out and we get 3. So now we have 21 root 15 plus 4 root 15. So you have 21 tens plus 4 tens. 21 root 15s and 4 root 15s. So when you add 21 and 4, you get 25 root 15 plus 14 into 3 is going to give you 42. plus 6 into 5, we all know is 30, divided by 9 into 5 is 45, minus 3 fours are 12. So we have 25 root 15, and in here 42 plus 30, which is going to give you 72. So we have 72 in here, divided by 45 minus 12, which gives you 33. Now we know that from 25 and 72, you cannot take anything in common. And definitely that if you cannot take anything in common, you cannot divide by 33 in here. So this answer that we have got is our final answer for this sum. If you could have taken anything in common, you would have taken, just like the previous previous sum that we did, you could have taken a number common and then do it. But if you cannot take anything in common, then that is the final answer. Now let's move to the next one. In this case, see, we have in the numerator, we now don't really have one simple fraction that was given to us earlier. We have three terms in here, one of which is a fraction. So root 2, you cannot change anything with it. You cannot do anything with it. So you keep root 2 as it is. And there is 1. 1 cannot be simplified any further. So you keep it as it is. Instead of root 2, if we had root 20, let's say we had root 20 in case of root 2, then you would have gone for simplification. But you know that root 2 is already a prime number. Root 2 is a square root of a prime number. So you leave it as it is. And in the fraction in here, you see the denominator contains a root. So this definitely is a problem for us and we need to remove the root. Now, how do we remove this root? We remove this root by multiplying with the conjugate. What is the conjugate? The conjugate is the one that contains the opposite sign of the one in the middle, of the sign in the middle. So we have a plus sign in here. So we will change it to a minus to get the conjugate. So what will we do? We will multiply with 1 minus root 2 in both numerator and the denominator. So now what we will get is root 2 will stay as it is. There is no problem with it. 1 will stay as it is. Again, no problem with it. But we have a problem with this one, which we need to sort out. And 1 multiplied with anything gives you the same number. So in the numerator, you will have 1 minus root 2. But in the denominator, what do you get? In the denominator, you have 1 plus root 2 and 1 minus root 2. So 1 plus root 2 and 1 minus root 2, you know that when you multiply 1 plus root 2 with 1 minus root 2, you are going to get a square minus b square. That is what we have seen in all of the sums while solving these kinds of problems in rationalization. So we get 1 minus root 2 in the numerator, and in the denominator we have a square minus b square. A is 1, b is root 2. So we have multiplied these two. So what do we get? We have root 2 plus 1 in here, and then in here we have 1 square is 1, then root and the square gets cancelled out. So we are left with 2 only. So we get root 2 plus 1 minus root 2 divided by 1 minus 2 is minus 1. Now we know we can take LCM. So if you take LCM of minus 1, what do you get? You know, multiplying anything with 1 gives us the same result, but because we have a minus in here, because of this minus sign in here, what will happen? These signs will change. So root 2 will become minus root 2. Minus 1 with 1 will become minus 1. And because this minus 1 fully divided this 1 minus root 2, the sign in here won't change. So when we simplify, we get Minus root 2 minus root 2. Minus x gives us minus 2x. Minus 5 gives us minus 10. So minus root 2 is going to give you minus 2 root over 2. So minus 2 root over 2. And then minus 1 plus 1 is 0. So we do not write it. And then we have divided by minus 1. Now we know that there is only one number in the numerator and one number in the denominator, and you can simply divide it. So this minus and this minus will get cancelled out, and anything divided by 1 gives us the same value. So our final answer is 2 root over 2. If you have 6 divided by 3, you can cancel these two out and your final answer is 2. But if you have 6 plus root 3 divided by 3, then you definitely cannot cancel this 2 out. You cannot do so. Or if you wish to do this, you cancel these 2 out. This is also a wrong method. You cannot do so. You can only divide them when you have one number in the numerator and one term in the denominator. One term in numerator and one term in the denominator is eligible for the crossing out techniques that we have seen. With this, we are done with understanding the second method of rationalization. In the next one, we will try to see more examples of simplification of surds and rationalization to help our understanding. With this, we are done with today's lecture.